Hi, in this video, I will be demonstrating the execution of our project. Our project involves making use of AI to actually help students learn. Rather than giving them the complete solution, our AI agent is responsible for building a step-by-step process and guiding the user to achieve whatever task they want to build. For this particular scenario, we have trained the AI agent to work on MuJoCo. MuJoCo is an open source physics based simulation software which is used in robotics for simulation. It is one of the most popular open source simulation softwares, but it has a steep learning curve. To simplify this problem, uh, we trained the model on MuJoCo's documentation and we used all the data that is available on the documentation to come up with solutions. We have a Coming to the working of our code, we have a watchdog that observes for any changes in our workspace. And when we run the code, let's say for example I want to start building a robot or a block which moves downwards when I apply some force from the top. So I can just be starting the program. Once I start the program, it gives me a step on what I need to do. So let me move this around to make it more visible. Yep. So the instruction I was told is, let's start by defining the MuJoCo model in XML format. Begin by creating a variable named model and set it to a multi-line string that starts with MuJoCo tag. What should be the next tag inside the MuJoCo? So it similar to this, it starts teaching you on how you can do it. So let's start by creating a model and make it a string with MuJoCo. So what should be inside the body? We have world body. Now if we are unfamiliar with the terms, then it is fine. The model will start explaining it as we go on. So let me just take a template body design that I have. So the XML can be found online. Building an XML is not the challenging part of MuJoCo, but rather the Python code that is needed. So this is a simple MuJoCo code or MuJoCo XML that generates a block, creates a joint for the block. A joint can be something that can help the block move around, and this is just the geometry of the box. An actuator is what is actually responsible for generating motion. So let's start with the next step. So let's start off with importing MuJoCo and MuJoCo viewer. So the model is telling me to make a function with your model XML string as the input. So I do not need to make a function. I can if I needed to, but for simplicity, let's just make a variable. Great. So now it is telling me to create the data structure for the model, and it is telling me what I could use. with the model as the argument and assign it to a variable named data. So let's try that. So data is equal to that model. So if I were to make a mistake, let's say I need to pass in the argument model, and it is telling me to use model as an argument. So it will not go forward until I fix my error. So it is trying to tell me that I've made a mistake, what mistake I've made, and how I can fix it as well. So this is a great learning tool, I would say, which can help you understand what each line of code does and how we can build a good simulation with it. Now it is telling me to use MuJoCo viewer.launch with model and data as arguments. So let me do that. So I will be doing a passive launch rather than just launch, and I'll call it viewer. So this is one good example of why we would not want to use AI. It just autofilled for me, but I have no idea what those code actually means. So let's see. So it's asking me to create a loop and have data control and apply a force. Great, so let's do that. Let's just have a range of 1000, for example. We give data dot control. So I want to apply downwards force of 5 Newton to the data. And now it is telling me to have steps. Okay, let's do that. Okay. It is asking us to update the scene. So we could use this update method, which is no longer supported. Actually, this is a good example of why the documentation cannot be completely trusted at the moment, and this is one of the challenges we are trying to overcome in our future expansion of this project, where we are trying to use more accurate data as the input for the model. So now that method is replaced by viewer.sync, which performs the same way. So now that the code is ready, let us run the code to see how this model behaves. So I have a code and I have a terminal window open. The way you run MuJoCo files is you run mj python. So it closed immediately. So this is a simple fix. We just need to add delay. So for each step, I'm adding a delay of 0.1. Let's run the code again. So this is our block, and as you can see, it is slowly dropping down. Yep. So this is a quick example of how we can use our AI agent to help you study and understand any concept. This does not have to be with MuJoCo. It can be with any documentation on the internet where it can be ROS, for example, it can be Python, it can be C, C Sharp, API development. So as long as you have a document, this can create a step-by-step study guide, I would say, to help you understand what each line of code is doing, how it can be improved, and what options you have.